Okay, dear students, today we will talk about the lattice vibration in which a chain of two types of atoms is involved. And what is the difference? The difference is that the masses are different. That is, one is mass capital M and other is mass small m. And they are attached with each other with springs, because basically this is the force with which they are attached, and we are representing that force as Hooke's law force. So we talk about the spring constant, that is K. So we say that atoms are attached with each other by springs of spring constant K. So what we say, two different types of atom of mass capital M and small m are connected by identical springs of spring constant A. Now spring constant A is identical, spring constant K is identical, that's why we say these springs are identical. Now this is the simplest possible mode of an ionic crystal. Now if you consider the ionic crystal, for example that of sodium chloride, then in that case, if I take this mass as chlorine mass, this will be the sodium mass, this will be the chlorine mass, again the sodium mass, and so on. And they are alternately changing along a particular line. That's why we say it's a chain of one-dimensional springs in which masses are attached with each other. Now, a repeat distance, which we call as the lattice constant, is between this m and this m, which is equal to A. So naturally, the distance between this m and small m will be A divided by 2. We call it as near neighbor distance. Similarly, the distance between this atom and this atom will also be A divided by 2. So this is the situation. Now you see, if they start vibrating, then this spring will be elongated and this spring will be compressed. So if I talk about this mass, then elongated, it means the restoring force in this spring will be in this direction, whereas the restoring force in this spring will be in this direction. So we say that we will use the Hooke's law and find the equation for this. We will consider only the first neighbor interaction, that is only the nearest neighbor, although it is a poor approximation. Why it's a poor approximation? Because in ionic crystals, atoms ions are attached with each other by Coulomb interaction. And Coulomb interaction is a long distance interaction. That's why when I talk about the nearest neighbor interaction, it's a poor approximation. The model is complicated due to presence of two different types of the atom. Already we have done when we were considering only one type of atom. So if I consider here two different types of atom, then this will become a bit complicated. We try to obtain omega versus k relation, angular velocity versus wave vector relation for diatomic lattice. Why I said diatomic lattice? Because there are two atoms, one of smaller mass and other of bigger mass. Two equations of motion must be written, one for mass capital M and other for mass small m. So when I talk about the mass capital M, I can write this is your force, this is second derivative of the distance, which is acceleration, m into a, kun plus 1 minus un. What is kun plus 1? This is kun plus 1, and this was the equilibrium position which is displaced by un. So I'll say kun plus 1 minus un. Similarly, on this side, minus kun minus un minus 1. kun minus un minus 1. You see here, this was the initial position. Now it is displaced to this position. So the displacement for this atom, the equation for Hooke's law for this atom is kun minus un minus 1. So you see here it is positive because this is pushing in this direction and this is pushing in that direction. So we got these two, kun plus 1 minus, if you multiply this with k and add them together, you will get this relation. kun plus 1 minus 2un plus un minus 1. This is for the mass capital M. Exactly in a similar way, for the smaller mass, I can write m into un double dash, which is basically m into a, kun minus 1 minus un minus 1 minus kun minus 1 minus un minus 2, exactly in the same way. And if I multiply this with k and add them together, I will get m into un minus 1 double dash, which is mean m into acceleration of which mass? Of smaller mass, kun minus 2un minus 1 plus un minus 2. So this is the second equation, for one for the capital mass and other for smaller mass. This is mass into acceleration, this is mass into direction. And this is what? This is the net Hooke's law force. And this is the net Hooke's law force for smaller mass. So we say I am using basically the elastic region of the oscillation of the masses. I am not stretching this spring too much. I am not compressing this spring too much so that they cross the elastic limit. Already, if you remember, when I talk about the elastic limit, if I say this is your strain and this is the stress, then stress is directly proportional to the strain in this region. So this is the elastic limit, or we can say elastic region for the Hooke's law. Now we got these two equations, and solution of these two equations will be of this form: un a e raised to the power iota kxn naught minus omega t, where xn naught is given by n into a divided by 2. And similarly, for smaller mass, I will have an equation which is the solution of this equation, that is which one? The second equation. This equation. Solution of this equation will be the second one, which is given by this relation un minus 1 is equal to alpha into a e raised to the power iota kxn naught minus omega t. Here alpha is a complex number which determines the relative amplitude and phases of the vibrational wave. You see, here there is only a, and here I am saying it's alpha. So what is alpha? It's a complex number which determines the relative amplitude and phases of the vibrational wave. Now we got this equation un, that is the displacement from the mean position, and this is u of which mass? Of capital M, and un minus 1, this is for the smaller m. Now if I differentiate it twice with respect to t, so what I will get du by divided by dn. Again d square u by dn square, I will get this un double dash. Differentiating this one, this will appear as minus omega square a e raised to the power iota k x n naught minus omega t. So this is the second derivative of this equation. D square un divided by dt square, second derivative of this equation. Exactly in a similar way, I can find the second derivative of the other equation, but before going into that, I will try to solve this equation. Substitute this value of un plus 1, un and un minus 1 in a previous equation. Which equation? The equation which was here, this one. Substitute the value of un double dash, un plus 1, un and un minus 1 in this equation. So what I will get is this one, m into un double dash k un plus 1 minus 2un plus un minus 1. Substituting the value un double dash, I will get minus omega square m into a e raised to the power iota k into n into a divided by 2 minus omega t. K un plus 1 alpha a e raised to the power iota k n plus 1 into a divided by 2 minus omega t minus 2 un a e raised to the power iota k n into a divided by 2 minus omega t plus un minus 1 alpha a e raised to the power iota k n into a minus 1 divided by 2 minus omega t. So this equation I got just by substituting the values which I have already written. I can write it like this: minus omega square m into a e raised to the power iota k into n into a divided by 2 minus omega t, the same equation. This I can write k alpha into a e raised to the power, so you see here, k into n into alpha divided by 2 minus omega t, k into n into alpha divided by 2 minus omega t, and this is k into 1 divided by 2 into a, so iota k into n into a. So I have split it up into this one and this one. If you multiply this value with this value, you will get this. And similarly, I will write this thing as it is: minus 2 alpha 2a into e raised to the power iota k into n into a divided by 2 minus omega t. And again, this I can write, this is a negative value. So here it was positive value, here it is negative value. So I write alpha into a e raised to the power iota k into n into a divided by 2 minus omega t multiplied by okay, I can write this equation in terms of this. I've split it up, this e raised to the power iota k into n plus 1 multiplied by alpha divided by 2 minus omega t into these two terms, and this e raised to the power iota k n minus 1 into alpha divided by 2 minus omega t into these two terms. Now you can see that this thing, e raised to the power iota k into n into a divided by 2 minus omega t is here as well as here. So I can take it common, and if I take it common from both sides, so it will be like this. You see, these things are common, and if I remove them, common, I can cancel from the left hand side and the right hand side, if I cancel them, what is left with me will be these values. This one, minus omega square into m, this is cancelled. K into alpha, e raised to the power iota k into a divided by 2, this term is cancelled. And similarly, here only 2 is left, this term is cancelled. And here your alpha into e raised to the power minus iota k into a divided by 2 is left, the rest is cancelled. Now, by using this relation, e raised to the power iota x plus e raised to the power minus iota x divided by 2 is equal to cos of angle x. Or you can write e raised to the power iota x minus e raised to the power minus iota x, multiply it here, it will be equal to 2 cos of x. Now what is x in this case is your k into a divided by 2. So I can write, if I substitute this value here, इन दोनों की जगह आप 2 cos of iota k into a divided by 2 लिख लें. So what you will get is this equation. Negative sign will cancel. This equation will be omega square into m is equal to 2k 1 minus alpha cos of k into a divided by 2. So I got this equation. This is just by substituting the value e raised to the power iota k into a divided by 2 plus e raised to the power minus iota k into a divided by 2 is equal to 2 cos of, something is wrong somewhere here, that we got this equation from this equation by substituting e raised to the power iota x, e raised to the power minus iota x. What is x in this case? K into a divided by 2. So I can substitute this value and I will get minus omega square into m, 2k 1 minus alpha cos of k into a divided by 2. Now note this equation as, for example, equation number 1. In a similar way, I will go for the other equation. Which equation? For the smaller mass. For the mass small m. So I can write m into second derivative of the displacement k un minus 2 un minus 1 plus un minus 2, and substitute the values of this un minus 1 double dash from the previous value. So you will get minus alpha into a into omega square into m e raised to the power iota k into n minus 1 divided by 2 into alpha minus omega t. And on the other side, also substitute the value of un minus 1 and un minus 2. This is the value of un, this one. This is the value of un minus 1, and this is the value of un minus 2. Now again you can see that in these equation on the left hand side, iota k into a minus 1 divided by 2 into alpha. So I can split it into two parts, e raised to the power iota k into n into alpha divided by 2 minus omega t multiplied by which value? E raised to the power iota k into a divided by 2. Similarly, this value I can also substitute by the corresponding values, and what I will get is this equation. You see here, this I have split it into this one and this one. This I have split it into this one. This I have left like this, and this I have split it into this one and this one, and this I have split it into this one and this one. Again you can see that a e raised to the power iota k into n into a divided by 2 minus omega t is here a e raised to the power iota k into n into a divided by 2 minus omega t, the same value, the same value. So I can take the common thing out, and if I take the common thing out, what I will get is this one. Cancel this one with this one, with this one, with this one. So what I will get is minus alpha into omega square into m e raised to the power iota k, this value, k into a divided by 2 is equal to k, this value, into this will become 1 minus 2 alpha, this will be cancelled, multiplied by e raised to the power iota k n into a plus e raised to the power minus iota k n into a. So this value we got from the above equation. Again, using the same formula which I have done in the previous equation, I can write this one. I can take this value down here. So what I will get is, what is left with me, minus alpha into omega square into m. If this goes down, 1 divided by e raised to the power minus iota k into a divided by 2. So it will become e raised to the power iota k into a divided by 2 minus 2 alpha plus 2 alpha into e raised to the power minus iota k into a divided by 2 plus e raised to the power minus iota k into a divided by 2. So I have divided this thing throughout. So this is cancelled with this, and this will become minus iota k into a divided by 2, and this will become plus iota k into a divided by 2. And I can write again e raised to the power iota k into a divided by 2, e raised to the power iota x plus e raised to the power minus iota x, as in the previous equation, is equal to cos of x. So this equation I can write like this, and this will give me, अगर इसको आप इसमें substitute कर लें, so you will get minus alpha into omega square into m is equal to 2k, because this is 2, cos of k into a divided by 2 minus alpha. So this is the, I will take, that was the first equation, and this is the second equation. Duster. Alig stop. I will use these two equations once again. Which equation? This first one, which was your where it is going. One for the capital mass. This was the equation. Omega square into m, capital M, is equal to 2k multiplied by 1 minus alpha into cos of k into a, k into a divided by 2. This was the first equation. And similarly, I got this second equation from using the small mass. I got this equation, this one, minus alpha into omega square into small m is equal to 2k multiplied by cos of k into a divided by 2 minus alpha. So I got these two equations. And from these two equations, I will calculate the value of omega square m. And from here, if I use the first equation, I can write omega square into capital M is equal to 2k, multiply this inside, minus 2k into alpha into cos of k into a divided by 2. And I can take it on this side, you will get 2k into alpha cos of k into a divided by 2. Take this one on this side, 2k minus omega square into capital M. From here, I can find the value of alpha. Alpha will be equal to 2k minus omega square into capital M divided by 2k into cos of k into a divided by 2. So I got the value of alpha from this. What is this value? 2k minus omega square m divided by 2k cos of k into a divided by 2. Exactly in a similar way, I will take this equation and I can write as minus alpha into omega square into small m is equal to 2k cos of k into a divided by 2. Multiply this minus 2k into alpha. Take the alpha side on one side, so you will get here, take this on here, so it will become 2k into alpha minus alpha into omega square into small m is equal to 2k cos of k into a divided by 2. And from here I can take alpha common, so you will get 2k minus omega square into small m is equal to 2k multiplied by cos of k into a divided by 2. And from here I can find the value of alpha. So alpha will be equal to 2k cos of k into a divided by 2 divided by this quantity 2k minus omega square into m, small m. This is the value, 2k minus omega square. So this is alpha and this is also alpha. I got two values of alpha. Okay, one in this form and other in this form. Well, it is alpha, so I will say this equation will be equal, this alpha will be equal to this alpha. So what I can write is this value 1 alpha 2k minus omega square into capital M divided by 2k cos of k into a divided by 2. And what is this alpha? This is also alpha, so I can write it as 2k into cos of k into a divided by 2 divided by this value 2k minus omega square into m. This is small m. Okay? Then what I will do, I will cross multiply these, this one here and this one. And if I cross multiply them, I will get cross multiplication. One is alpha, there is also alpha. Cross multiplication. So you will get 4k square cos square k into a divided by 2 is equal to 4k square minus 2k omega square capital M plus small m minus omega raised to the power 4 into capital M into small m. And this I can further write like this. 4k square is here and 4k square is here as well. So what I can write? 4k square, 1, I will take this on that side, minus cos square k into a divided by 2, minus 2k into omega square, 2k into omega square, m plus m and plus omega square, omega raised to the power 4 capital M into small m. So is equal to 0. I will convert it into an equation which I can further write in this way. Omega raised to the power 4, this m into m I will divide throughout here. So this will be cancelled and you will get omega raised to the power 4 minus 2k m plus m divided by m into m multiplied by omega square plus 4k square sin square k into a divided by 2, because 1 minus cos square k into a divided by 2 is sin square k into a divided by 2. M into m is equal to 0. Now you see, here it is omega raised to the power 4. Here it is omega square. And here there is no omega. So what I can say, this is a quadratic equation in omega square. And if what is a quadratic equation? You have studied earlier that it is equal to ax square plus bx plus c is equal to 0. Here square, here single x, and here is no x. The solution of this equation for x will be equal to minus b plus minus b square minus 4ac under the root divided by 2 multiplied by a. This is the solution of the quadratic equation. Here the solution will not be in x form or omega form, it will be in the form of omega square, because this is omega 4, omega square and no omega. And its two roots will be like this. This is what I have written earlier. The two roots of this equation will be omega plus minus. Plus minus mean this is one is plus and other is minus. So I write omega minus plus or plus minus square is equal to this solution from here minus b. What is minus b? This is b. K into m plus m divided by m into m minus plus k b square m into m divided by whole square minus 4ac raised to the power 1 by 2, that is under root. And if you solve it, you will get this thing, two solutions, one for this one, this is minus plus, this is minus plus, so I can take once plus and second time I can take the minus value. So omega square I have calculated here in this case. So you can see that here for every value of k, which k? Every value of k, I have two values of omega, one with negative sign and other with positive sign. Omega value will have always a positive sign, but once we will use the negative sign of the equation and other we will use the positive sign of equation. So if I plot it on a graph, I will get this thing. this is your k axis and this is your omega axis. So you can see this is 0, k value is 0, mean when k value is 0, what is k? K is 2 pi divided by lambda, where lambda is the wavelength. When wavelength is very, very large, then k will be equal to 0. K is equal to 0 for lambda very large, very large. So for small value of k, or k is equal to 0, I will have the longer value of the wavelength. If I take any other value of k, for example, I take here, I have got one value on the downward curve and one value on the upward curve. So one value is here and one value is here. Even at k is equal to 0, I have two values. One value of k is equal to 0 here and omega is equal to 0 here. And when I take the same 0 value, omega has got a maximum value on the other branch. So I can say that if I use these two equations, I can find two dispersion relation or two curves. One is the lower frequency curve. You can see the maximum value of frequency on the lower curve is this value. And other is the high frequency curve. The minimum value is this one, but the maximum value is here. So we say that we have two curves for this type of the lattice in which two different atoms, one of mass m and other of mass small m, are attached with each other. Keep in mind, in all these equations, I have used k twice. 1k is this. 1k is this. This is the spring constant. And this small k, this is the wave vector. Okay, so don't be confused with this k and this k. They are not the same. This is the spring constant and this k is your wave vector. Okay, k is equal to 2 pi divided by lambda, and other k, f is equal to kx as we are, f is equal to minus kx as we are using it in Hooke's law of force. F is equal to minus k, capital K into x. Other k I am not using as a wave vector, I am not using as a spring constant. This k, this small value of k, you can write it like this. It is a wave vector which is 2 pi divided by lambda. So this wave vector changes with the value of lambda, whereas this value, capital K, which is a spring constant, remains the same within the elastic limit of the springs. So I am using the spring constant for spring constant capital K, and I am using the wave vector for small k. A is the interatomic repeat distance. As I have earlier told you, that A is basically what? A is the repeat distance. What is meant by the repeat distance? Similar atoms are repeating, this atom and this atom. The center of this atom and center of this atom. Between the distance, it is equal to A. And if I consider the center of this atom and center of this atom, it will be equal to half of the A, that is A divided by 2. This we can also call, this will be the lattice constant for a one-dimensional chain of two different types of atom. Okay, this is enough for today, and in our next lecture, we will continue from the place where we have left today. Thank you.